Hello students, welcome back to my YouTube channel. In this film, I'm going to explain the very first 5 questions of part A of Combined Mathematics paper 1. So to begin with, let me explain the first question. So before that, I have an announcement for you. If you are watching this video, please share this video with your friends so that they also can learn something new. And please make sure that you subscribe to my channel and comment if you have any ideas or any suggestions or any doubts. And if you subscribe only, whenever I upload new videos you will be notified. Okay, so with that news, I'm going to start the first question. So the first question is coming from principle of mathematical induction. So using the principle of mathematical induction, so I'm going to take 2019 combined mathematics 1 first question. Okay, right. Now, using the principle of mathematical induction, prove that summation of r is equal to 1 to n 2r minus 1 is equal to n square for all n belongs to positive integer. Okay, so you know how to approach this kind of question. So this is basically from principle of mathematical induction. So in the first step, you have to show that the result is true for n is equal to 1. Then you have to assume the result is true for n is equal to p. And then you have to show that the result is true for n is equal to p plus 1 as well. So when okay, now n is equal to 1. For n is equal to 1, now I'm going to take LHS. Left hand side is equal to summation of r is equal to 1 to, okay, you can take. So this is a series. So instead of r, I'm going to put n here. So r is equal to 1 to n means we have n terms, right? So 2 into, so instead of r, I'm going to put 1 minus 1 is equal to 1. And if I take RHS is equal to n square, that is equal to, if I substitute n is equal to 1, I will get 1 square is equal to 1. So LHS is equal to RHS, the result is true for n is equal to 1, you have to write. And then next step is, you have to take, or you have to assume the result, the equation. So assume n is equal to p belongs to z plus. Okay, so you have to assume that the equation or this expression is true for n is equal to p. So if I substitute n is equal to p, summation of r is equal to 1 to p 2r minus 1 is equal to p square. Okay, this is what I have assumed. And I have to add the next term with this expression in the series. And so the next term will be, instead of r, so if I have p here, I will put p. Instead of r, I will put p in the last term, for the last term. And to find out the next term, that means p plus 1 term, I have to put p plus 1 instead of r. So I have to take, so yeah, now let me use a different color. So here 2p plus 1 minus 1 will be equal to 2p plus 1. So 2p plus 1 is the next term. So I'm going to add this term with this in the both side of the equation. So I will get this is just my color. Okay, so this will be equal to add, so you have to add 2p plus 1 in both sides. Okay, so summation of 2r minus 1, r is equal to 1 to p plus 2p plus 1 is equal to p square plus 2p plus 1. Now this is going to be equal to, now with this summation, if I add 2p plus 1, it will become r is equal to 1. Now instead of p, I can put p plus 1. So I have So I have p plus 1 terms into 2r minus 1 is equal to, so this can be written as p plus 1 whole thing square. Now I have assumed that the result is true for n is equal to p, and I have proved that the result is true for p plus 1 as well. So therefore, according to principle of mathematical induction, the result or whatever, the result is true for all n is equal to p plus 1. So ultimately you have to write that sentence. So this is very simple. This is the first question you will face in your mathematics 1. I mean, so normally combined mathematics will be held first in your A-level examination. So when you receive the paper, this question will appear in your exam paper, and first impression should be always best impression. So without any confusion or without making any mistake, you have to get the answer and continue your exam paper. Okay, so let me move to the second question now. Right. The second question says, sketch the graph of Okay, now we will move to the second question. Okay, right. Second question, sketch the graph of y is equal to mod of 4x minus 3. Y is equal to mod of 4x minus 3, and y is equal to 3 minus 2 mod of x in the same diagram. Hence or otherwise find all real values of x satisfying the inequality. After that, we have to find the x values of the all real values of x satisfying the inequality. This x value should satisfy the inequality of 2x minus 3 mod plus mod of x less than 3. Okay, so this is also a very simple question. Okay, so I'm going to take a coordinate axis. So let me draw the coordinate axis here. So this is x and this is y. So first I have to find out the critical points. So I have to take the expression within the modulo symbol and equate it to 0 to find out the critical points. I mean where the graph will reflect without going to the negative part. So now if I take 4x minus 3, 4x minus 3 is equal to 0, x is equal to 3 by 4. So at this point, x is equal to 3 by 4, let's assume 3 by 4 is somewhere here. So now we have two kinds of graphs. Now modulus of 5 means it can be plus or minus 5. So this also plus 4x minus 3 or minus into 4x minus 3. So y is equal to 4x minus 3 can be an equation. Then the next equation is y is equal to the minus of the expression within the modulus. So that is equal to 3 minus 4x. Okay. Now this also can be, now if I equate the expression within the modulus symbol to 0, x will be 0. Then the next critical point is x is equal to 0. Let me take this is equal to 0, 0 origin. Okay. So then x is equal to 0. These two are the critical points. Right. Now again, if I use this one here, y is equal to 3 minus 2x and y is equal to 3 plus 2x. So these three will be the graphs. Okay. Now I have to draw all these graphs on a same diagram. Right. Now what I have to do is, now here and here we have, so x is equal to 0 and x is equal to 3 by 4, we have critical points. Now I am going to draw x is equal to 4x minus 3. So 4x minus 3 and its critical point is 3 by 4. So the intercept is here minus 3. So, and here the intercept is 3. So, let me take this as 3 and this as minus 3. Okay. So, if I draw the diagram here, so if we, since we have used modulus, the graph cannot go below negative, right? So, this will be now, okay. Right. Now this is one graph. So this is equal to minus 3. Intercept is minus 3 and 4x mean the gradient is positive. So the angle should be gradient. Okay. I mean the acute angle. So this is equal to y is equal to 4x minus 3 and the next graph is intercept is 3 and the gradient is negative. So obtuse angle, right? The angle between the x-axis and the graph will be obtuse. So here, let me take this as y is equal to 3 minus 4x. Okay, right. The next one is I have drawn this diagram here. So this is equal to mod of 3 minus 4x. So the graph will not go below the x-axis. Right. Now the next one is this one. Y is equal to 3 minus 2x. Now here also the intercept is 3. The intercept is 3 and we know that when we equate the expression within the modular symbol to 0, we get 0. It is equal to 0 as the critical point. So the graph will reflect here. I mean above that it will not go. Okay, right. Now 3. So definitely it will go through. The graph will go through 3, right? So it will go like this. So it will go like this. Now we have a question. Right. Now I have to find out at which point the graph will intersect the x-axis. So when y is equal to 0, when y is equal to 0, x will be so y is equal to 0, so I can put 0 here, is equal to 3 minus 2x. So x is equal to 3 by 2. So here it will, 3 by 2 means it will be somewhere here. So if this is 3 by 4, let me take this one and like this. Okay, so this is 3 by 2. So the graph for this one is this. Okay, so this is equal to y is equal to 3 minus 2x, and the next one is here when y is x is equal, I'm sorry here, yeah, when y is equal to 0, we have to find out where now if you look at this one, the intercept is 3 and the gradient is positive, so it will be like this because the angle should be acute. So when y is equal to 0, 0 is equal to 3 plus 2x, so x is equal to minus 3 by 2. Minus 3 by 2 is somewhere here. Right, I have drawn both the diagrams on the same diagram. So the first part is okay. Now, then they are telling 2x minus 3 plus x, 3 should be here. Now, if you look at these two, now 4x minus 3, instead of 4x minus 3, we have 2x minus 3 here, and we have 3 minus 2 mod of x. Okay, so now if I bring this one to this side, okay, so 2x minus 3 mod is less than 3 minus mod of x. Okay, so I want to compare these two graphs. Okay, so what I am going to do is now I have to obtain 4x here. So I can replace x is equal to 2x. Okay. So if I replace x is equal to 2x, I will obtain 4x minus 3 is less than 3 minus 2 mod of x. Okay. Right. Now I have to find out the area or the x value satisfying this inequality. From that I can find the x value satisfying this inequality. So 4x minus 3, okay, so let me use a different color to indicate this. 4x minus 3, okay, 4x minus 3, so 4x minus 3 means like this one. 4x minus 3 should be less than 3 minus 2x. So this should be the graph which I have marked in black color should below this graph which I have marked in blue color. So black color should be below then blue color. So that's what I'm going to find here. Okay. Right. Now black color is within this range. Within this range, the blue color graph is above black color one. So I need this x value. So to find out this one, these two lines intersect. So if I equate these two equations, I will find out the x position. Okay, right. Now y is equal to 4x minus 3 is equal to, so I don't need to write this and this intersect. So I can tell y is equal to y means I can equate this and this. This is equal to 3 minus 2x. So here 6x is equal to, now 6. So x is equal to 1. So this value is 1. So the x value satisfying this inequality is 0 less than x less than 1. Right. Okay, now this inequality is satisfied by this x value. But here I have replaced. So, but here what I have done is I have replaced x by 2x. So instead of x, if I replace x by 2, I will get this one. So if I put x is equal to 2x. So instead of x, if I put x is equal to 2x, I will get this value. Right. Now what I have to do is simply replace x is equal to 2x here. So this range will be 0, x less than 2. So this is the answer. Okay. Replacing x is equal to x by 2. So here I have replaced x by 2x. So I just multiply this way. So what I have done here is, you don't need to confuse here. So here, right, now if I multiply this by 2x, I will get this inequality. So just by multiplying this inequality, this x value by 2, I will get the values satisfying this inequality. That's all. So in other way, how you can do is, okay, now I have done in other way around. I mean, taking the answer, I have shown the question, but taking the question, you have to get the answer. So, okay, now I have, okay, now let me erase all these. Okay. Right, now, this is what I have to show. Okay, so this is the question, this is the answer. I mean, this is what I have to find out, the x value satisfying this inequality. But I know I have the relationship between this graph and this graph like this. So I have found out the x value satisfying this inequality is 0 less than x less than 1. Now I need to find out this inequality. So how I can acquire this inequality is just by replacing x is equal to x by 2, I can obtain this value. Okay, right. Okay, so what I have done earlier is a bit wrong, because I should have replaced x is equal to x by 2, because I'm coming from reverse. Okay, so if you do like that, that is not no okay, because you are taking the answer and showing the question, but this is the proper way. So replace x is equal to x by 2. So this will become 2x minus 3 mod of less than 3 minus mod of x. So the range also will, so instead of x we can put x by 2. 0 less than x by 2 less than 1. So I need x value. So 0 less than x. So I just multiply this 2 by 0 and 1, so I will get 2. So this is the x value satisfying this inequality. Hope you have understood the second question also. Let me move to the third question. So third question is basically coming from complex number. So the third question says, sketch in an Argand diagram. So Argand diagram, to represent complex number we use Argand diagram. So we will have imaginary, real. Okay, so in a complex number we have, for example, a typical example for complex number is z is equal to a plus bi, right? So this is real part and this is imaginary part. So we mark real part in the real axis. So this is not actually x-axis represents real axis and imaginary axis, right? Now they are telling in an Argand diagram, the locus of the points that represent complex numbers that satisfying argumentation. Argumentation is the angle between the complex number and the x-axis. Argumentation of z minus 2 minus 2i is equal to minus 3 pi by 4. Okay, so we have to sketch this this complex number. So what I have to do is I just equate this to 0 to find out the real number. So that is equal to 2 plus 2i. So I will get this as z. And this is argumentation. Argumentation mean, okay, so z is equal to 2 plus 2i mean, okay, now this is real part is 2, so let me take this as 2, and imaginary part is also 2. So from here, so from the origin, this will be the z. And normally the argumentation or the angle is measured from this direction. Okay, from this direction. But the minus indicates, so from the x-axis it is measured below. So it will be minus 3 pi by 4 means this will be minus 3 pi by 4. Right. Now this is the third question. Third question is coming from complex number. So you should know this is the typical representation for complex number. We have a real part and imaginary part, argumentation, and we have modulus also. So modulus of z will be equal to a squared plus b squared or the square. So these things you know, right? With that, I will move to the fourth question. Right, show that the coefficient. Fourth question. Show that the coefficient of x to the power 6 in the binomial expression of x cube plus 1 over x squared holding 7 is equal to 35. So x to the power 6. So coefficient of x to the power 6 is this. We have to show. Okay. Right. This is the binomial expression, and you know. So for example, x plus y to the power n is equal to summation of I is equal to naught to n NCR x to the power r into y to the power n minus r. So this is the expansion of a binomial expression. So if I apply this equation directly to this one, okay. So how I can write this is, so n is equal to here 7. So x cube plus 1 over x squared to the power 7 is equal to summation of I is equal to naught to 7. Okay, I is equal to 1 to 7. Yeah, I is equal to, or r is equal to. Okay, so here r is equal to naught to 7. N is equal to 7 CR x to the power r y to the power, here x is equal to x cube. x cube to the power r into 1 over x square to the power 7 minus r. Now I have to simplify this. So summation of r is equal to not to 7 CR okay 7 CR x to the power 3r. Now using the rules of indices, I can bring this x square to the numerator, so it will become x to the power minus 2. So x to the power minus 2 into 7 minus r would give you minus 14 plus 2r. So we have already 3r, so it will become 5r plus 17. Now we have to find out the coefficient of x to the power 6. So this should be 6. So for that I have to find out r. Okay, so 5r plus 17 would equal to 6. So here r is equal to 17 minus 6. It will not work because r should be belongs to z plus. So I get 11 divided. I'm sorry. So this is 14. Okay, so 14 means it will be 8. Okay, 8. So r is equal to 4. Now the coefficient is this. So just by replacing r is equal r by 4, I can get the coefficient. So coefficient of x to the power 6 is equal to I know this one. So 7c4. So that is equal to 7c4 means 7 factorial over 7 minus 3 factorial into 4 factorial. So this is equal to 7 into 6 into 5 divided by 3 into 2. So 35 would be the answer. Okay, right. So I have explained the fourth question also. Now we will discuss the fifth question. Now we will move to the fifth question. With the fifth question, I will conclude this video and the remaining questions will be uploaded in another video. Okay. So limit x tends to 3, x minus 2 square root minus 1 divided by sine pi into x minus 3 is equal to 1 divided by 2 pi. So this is what I have to show. So this is very simple. Okay. So what I have to do is I have to multiply the fraction by its conjugate. So limit x tends to 3, x minus 2 minus 1, and its conjugate is divided by sine pi into x minus 3. So you know everything, right? So this is very simple. X minus 2 minus 1 plus 1 is the conjugate. So divided by x minus 2 plus 1. So I can rewrite it as, so a minus b into a plus b will be x minus 2 minus 1. Okay, so the square root of this is x minus 2 and minus 1 square is minus square. So limit x tends to 3 divided by sine pi into x minus 3. Right, so again it becomes 0. So I have to eliminate this is not equal to 0. So I have to use that is I have to show that is equal to 1 into 1 over x minus 2 square root of plus 1. So it becomes x minus 3. So I can write x minus 3, and I can bring this x minus 3 over here, x minus 3. And since I have pi into x minus 3, I can multiply this by pi. And if I multiply this by pi, I have to multiply this also by pi. I'm sorry, I have to divide it by pi. So it will become 1 over pi means it will become here, okay, into 1 over pi. Now I can tell this is equal to 1. This is equal to 1, and now if I substitute limit x tends to 3 here, 3 minus 2 is 1. Again 1 plus 1 2 into pi, that is equal to 1 over pi, 2 pi. So This is very simple. So I hope you have understood all 5 questions that I explained in this video. And in another video, I will upload the explanations of the remaining 5 questions and step by step. So I am unable to record lengthy videos because of some technical issues. So I am uploading short videos for each question. I am uploading each question. So make sure that you watch the videos till the end and subscribe to my channel. Thank you. We will meet in another video.